So exceptions. Exceptions are something that you don't want happening when you run your program because it stops running. You end up going back into Visual Studio. It shows you a little square box that says an exception has occurred, and that is not going to be something that you're going to want to see when you are trying to test your programs. So exception handling actually allows the program to continue running when an exception occurs. Typically, you display a little message indicating what the problem is, but it doesn't throw you back into Visual Studio and halt the execution of your program. So, exception handling is something that exists in pretty much all languages, including web languages like JavaScript. And how it works is any code that you think could cause an exception. And that would be code that the user enters. Okay. Anything that a user is going to enter can cause a problem. You will enclose that in a try block. Immediately below the try block, you will have a catch block. So if there is a problem or an exception, it will come down to the catch block and it will run, display the errors, do whatever you tell it to do. Okay, so try and catch are required. There's a third component to this called finally. The finally block will always run, even if there is not a problem. So you might run the try block, everything runs perfectly, so catch doesn't run. Finally will always run. So where you're going to see this is if you're using resources like files. Let's say in your try block, you've opened files and you're writing to files. Okay. Well, regardless of if there is an error or not, you're going to want to close the files. Okay. And that type of thing is done in a finally block. So that's kind of in a nutshell how this works. So here we've got a contrived error, division by 0. That is going to cause an exception, right? So we got this little program. You can see unhandled exception, and then the program stops running. So we can add exception handling to this. So the code that has the possibility of throwing the exception, we put in a try block, and then right below that, we have a catch block. And if you're looking for a specific type of exception, you can actually put the name of the exception in. And I do have a table with the different exception types that I'll show you. Okay. And so that will allow the program to continue running. Okay, and you can see I put a finally block in here, which honestly doesn't do much. I don't include finally blocks unless I am file handling or if I have some resource open that needs to be closed. Okay, but you can see it always runs whether there's an exception or not. Let me show you the different types of exceptions. No, there is a table in here. It's pretty far down. Come on. All right. This gets into the different types of exceptions that there are. Okay, so this table kind of lists them all. And the one that you guys are going to be using in the lab is format exception. And that is when the user enters the wrong data. And that is actually something that can happen with users. So you will be creating a catch block with format exception, and then you'll also be doing a default catch block. So these are all the different types of exceptions. Okay. And then there are also different properties that you can access, such as the exception message and the exception source. Okay. And so we'll take a look at how to code all of that stuff. Let's look at a couple more examples. Okay. So this is another example. And so enter a whole number greater than 0. And so here you can see we're not only reading in the number, we are using try parse, which int.try parse, which is basically checking to see if it's an integer or not. And if it is okay, it's going to output number 1. If it's not okay, we're going to stay in this loop until they give us a valid number. Okay, and so by the time we get out of the loop, we have a valid number 1. And so here we're telling them again, enter a whole number greater than 0. We get into another validation loop. And this time, it's checking to make sure it's a number. And if it is, it's going to output number 2. And if it's not, it's just going to stay in the loop until they give us a valid number. Okay, and so at this point, we have 2 numbers. And so we're going to check to see if number 1 is less than 0 or number 2 is less than or equal to 0. Because even though we did tell them it should be greater than 0, they could have keyed in a 0. So basically, if they did a number less than or equal to 0, we're setting it to 1. And then we're also throwing an exception. Please enter a number greater than 0. And we're telling them we're going to use a default of 1 because they messed up. And so we're throwing a new exception. Where does that go? Okay, that will go here. This is where it is catching that exception. And the message is what we have in double quotes. So we're writing that out. Okay, and then finally, that is where we're actually going to do the arithmetic. Okay, and this actually works with finally, because if there is no exception, it's still going to go through finally and do the arithmetic. Now, normally you're going to do more than one catch block, especially if you're going to look for a built-in exception. You're probably going to want a default catch block as well. And you can kind of stack these catch blocks on top of each other. And you'll do the specific ones on top and the most generic at the bottom. So here, if you look for index out of range, basically that's indexing beyond the bounds of an array. Divide by 0. They're trying to divide by 0. Here, this is more generic. Okay, but that's an example of kind of stacking your catches. And then here is how it is used. So we do have an array in this example. We've got a couple variables that we're calling index. Here's our try block, which means this is the code in here that could throw an exception. Here we're asking them for an index number between 1 and 6. Okay, and all this is really doing is it's making sure that it's giving us an integer. And if it is, it's going to store it in index. Okay, and then here, it's kind of doing the same thing, right? Give us an index number between 1 and 6. It's making sure it's an integer and it's going to store it in index 2. Okay, then we get into this line. And this is actually where we could have an exception. Because if we're not checking to make sure that the number is between 1 and 6, okay? And so this is how long the array is. So if they enter a bad number, we'll probably get index out of range exception, okay? Or if they enter a number that retrieves the 0, we could get divide by 0. Okay, and then any other exception would be caught down here. Okay, and this is something that you actually can run, and you can just see how it works. You want to kind of play with that exception handling. Okay, so enter a number between 1 and 6. Let's see, we'll do 6. Let's try 1. Okay, and so that should be a problem. Let's try that again. Let's do 2, 4. All right, well, that one worked. Let's do 1 and 1. All right, can't divide by 0. That's what we would expect. Let's try this. 10 and 20. Okay, good. That one's working. 1 and 1. Okay, so it is working. I think there might be a little glitch in here, though. If I try doing like 5 and 1, that should definitely not work. So we'll have to take a look at that. But you guys kind of get the gist here of how the catch and the try are working. So what I normally use if I'm going to catch all exceptions is I just use the keyword catch. I don't put exception in here. I basically just do a catch. They're kind of interchangeable, okay? They're both a default catch. And the default catch has to go at the bottom. If you're going to stack up catches, it has to be the last one because it is generic. If you have it at the top, that is always going to be the one that executes. Your program will automatically throw an exception if you try to divide by 0 or you index out of bounds, any of the conditions that it normally checks. You can also throw an exception. Okay, so in your program, okay, you can actually check to see if an index is equal to 0, and you can throw your own exception. And this is kind of a workaround to the problem that we just saw in the previous program. Okay, so this is the previous program with a workaround for that little issue that we just saw. So what we're doing here is we are checking that second index, the value, to see if it's a 0. And since the system wasn't flagging it as an exception, we are flagging it as an exception. Okay, so let's test this one. All right, so we already know if I do a 1 and a 1, 0 divided by 0, the system is flagging it. Okay, the problem is if I do this and I divide it by 0, the system was not catching that. Okay, but now it is, and it's catching it because we are throwing the exception. Okay, all of the other exceptional conditions in this code, the system is throwing. This is the one that we're looking for. So you can throw a specific exception like this, divide by 0. You can also just throw a generic one. So instead of new divide by 0, I can just say throw new exception. Where's that going to go? That's going to go to the generic catch. Okay, throw divide by 0. That's going to go into the divide by 0. If we didn't have a divide by 0, then it would go into the generic. Okay, but this is something you could copy and run as well. So here is another little example. This is a heart rate calculator. And if they give us a bad age, what we're actually doing here is we're setting a default. And we are throwing an exception, but we're also telling them that we are using a default value. And we're doing the same thing with resting heart rate. Okay, and it's kind of a generic that we're throwing. This is where it's catching it. And because we're setting the default values, then the program can continue running. Okay, and it'll be just fine. So this is a method called calcrate. Here is our main program. And so you can see we've got age and resting heart rate. We are having the user enter the age. Okay, and so here we're basically validating that it is an integer. Okay, and as long as it's an integer, it outputs the age. And here we're doing the same thing for the heart rate. And as long as the heart rate is an integer, it's going to, store it in resting HR. Okay, and then we are calling calcrate and passing those values. So it's up in calcrate that we're actually validating the numbers. And that's where we're kind of setting these defaults. We are going to throw the exception and basically just to let the user know, hey, we're using these default values. But it's still going to go ahead and calculate the training heart rate, format a message, and it's going to return the message. Okay, so where it returns the message is here, and then we're printing it out. So you can actually see this run. So first we'll actually give it some good values, right? So it had to be between 10 and 100. So why don't we go with 45? Okay, resting heart rate, we'll say that's 60. All right, so I gave it good values this time. Now let me run it with bad ones. Enter your age. And we'll do 60 there. All right, so it did throw an exception. Age is out of range. A default of 50 is going to be used. And it still went ahead and calculated the heart rate using that 50 value. So rethrowing an exception, what the heck is that? So this happens if the exception occurs maybe in a method and the method, the catch blocks in the method just wants to throw it back to the main or the calling program. Okay, so Here we've got, let me just show you the full example here. We have a math method here. And so if the two values are equal, we're throwing an exception. If the second one equals 0, we're throwing an exception. So if either of those occur, we're going to come to this catch block, and all the catch block does is throw. That is what rethrowing an exception is. So where does that go? It goes back into the main method or the method that called it. In this case, it would be the main method. So we go through the try block, right? Enter an index number, enter another index number. Here we are calling the math method and we're passing it those index numbers. If there's a problem and it throws the exception, it goes into the catch and it does another throw. It throws to this point and then it looks for the correct catch to handle it. So if it's the index out of range, it's going to come in here. If it's divide by 0, it's going to come in here. Okay. If they can't determine what kind of exception it is, it's going to come in here. That is what rethrowing an exception is. Okay. And we did take a look at the different types of exceptions. And so if you are doing try catch and you're not familiar with these, I would take a look at them because you may want to format a catch for a specific type of exception. For a lot of what we're going to do, the format exception is what we are going to be using. If we get into file handling, file not found is a good exception to check for. When an exception is thrown, C# actually creates an exception object. And the exception object has a lot of properties that contain information about the exception. In order to display the data that's stored in these properties, when you do a catch, you not only have to tell it the type of exception, but you have to give this exception object a name. So you can call it E for exception or EX for exception, whatever you want to call it. But once you give it a name, then you can access these properties. So if you wanted to access the message property, you would use EX, which is the name of the exception object, dot message. Okay, so here we've got overflow exception. We're calling it EX, and then we write to the console EX.message. Okay, so here we are writing, if they index out of bounds, we are writing the message that came with the exception object and the name of the program. Divide by 0, we're doing the same thing. Okay, and so this is our lovely little index example again. So just so you can kind of see what those messages look like. We're going to go ahead and run this. Okay, so we're going to do a 1 and a 1. So cannot divide by 0 is the developer's message. Okay, and then the system, the object, so E.message has attempted to divide by 0, and E.source, where it came from, was the module called testing, which is what I gave the name of this project to. Okay, so I called the project testing, and that's where the exception occurred. So we can do it again. We'll do an index out of bounds this time. Okay, so the first message is the developer message. That's the one that I did. index was outside the bounds of the array. That is e.message. So that is the message property. And of course, this is e.source, which it's the source property. So you will get the opportunity in the lab to work with exception handling. And we're specifically going to be looking for the format exception. And I am going to have you pull in the exception object and display the message that the system generates. Okay, so you will get more practice doing that.